Nobody warned me the car was running a supercomputer. I was in the passenger seat. My colleague dropped his hands into his lap, and the car just took over, held the lane, took a banked curve, handled a construction merge on its own. Welcome back to Silicon to Software. I'm Imran Valiani. Today we're talking about the hardware underneath the modern car. Not the AI headlines, but the silicon and the circuit boards that actually make it real. So let's start with the basics. 30 years ago, a car had one computer, the engine control unit. That's it. Today's premium vehicle, it's got up to 150 of them, each one its own embedded controller, its own circuit board, handling one specific job: steering, braking, lighting, battery control. The car became a network of computers, running on multiple buses: CAN, LIN, Automotive Ethernet. Now some car makers are consolidating, moving toward 10 to 30 zonal controllers instead. But make no mistake, this is a distributed compute platform on wheels. Now, layer AI on top of that. Tesla bet on cameras alone, vision only. Waymo bet on cameras, radar, and lidar together, redundant, belt and suspenders. And here's the trade-off. Tesla's approach is cheaper and it scales faster. Waymo's is more expensive, but the safety data is hard to argue with. Waymo's rider-only fleet is showing dramatically fewer injury claims than human drivers on the same roads. Independent studies back that up. Both approaches run on deep neural networks, trained on real driving data, no handwritten rules, just pattern recognition at massive scale, running on custom silicon built to fit inside a car's power and thermal budget. Now let's talk about the part most people miss entirely. The EV transition, swapping a gas engine for a battery, didn't just change what's under the hood, it changed the entire electrical environment of the car. We went from a simple 12-volt system to 400, even 800 volts. That's a different universe of engineering. At that voltage, a tiny flaw, a contaminated coating, a bad solder joint, that's not a minor defect anymore. That can start a fire. So every automotive PCB near that high voltage system now needs serious isolation. Defined air gaps, certified coatings, careful spacing, calculated down to the standard. And sitting right in the middle of all this is the battery management system. Think of it as the nervous system for the battery pack. It's watching every cell, every second, voltage, temperature, health. And it has to work for 15 years in heat, cold, vibration, road salt, zero tolerance for failure. That's before we even get to thermal management. High-power electronics generate serious heat, so design engineers simulate every board's thermal behavior before it's ever built. Because here's the thing, catching a hot spot on a screen is cheap. Catching it after the car ships is not. And there's one more layer now, regulation. Since 2024, cars sold in much of the world need to meet strict cybersecurity rules. Think of it like this. Your car gets software updates just like your phone. And regulators now require those updates to be locked down, verified, tamper-proof. From the chip all the way up to the cloud. So here's the big picture. Building a modern car today means solving 4 hard problems at once. Heat, interference, safety, and security, all on the same board, all at the same time. That convergence, that's the real story of the modern vehicle. Not the demo video, the board underneath it. If you want the full technical breakdown of the standards, the source data, the deep dive, head to silicontosoftware.com, search Automotive PCB Design. It's all there. Thanks for listening. I'm Imran Valiani. This has been Silicon to Software.